is your groundwater storage. ये मुझे थोड़ा सा इसमें टाइम देना है मुझको, so please bear with me because this will need some time. ठीक है. When we talk about groundwater storage, मुझे कुछ चीजें let me just ask you, right? धीरे धीरे we'll clear it, and then you should have a good understanding of what is storativity, which is your storage coefficient, and specific storage. तो ये दो चीजें we have to understand. ठीक है. If you look at this figure, let's say it is a confined what you can say, confined aquifer. ठीक है. Now if this is a confined aquifer, Prakash, Pradeep, there, if you consider a surface area, एक hypothetical surface area ले लो aquifer के अंदर, ये दिख रहा है सबको? Can you see this surface area? Horizontal area A, any area, doesn't matter what is the area, just some area. ठीक है. So in this area there will be a pressure acting from top, which will be the pressure of the overburden, whatever rocks are lying above this aquifer. इस एक्यूफर के ऊपर जो भी रॉक्स, जो भी डेप्थ पे कुछ प्रेशर होगा, राइट? Now because of that pressure there will be some because of that material there will be some pressure on the aquifer, right? So stress हमें पता है, right? Stress is sigma t. If I want to calculate the force that is acting, I'll multiply with this area. If I'm talking about this area, then force will be pressure into area, right? This will be the downward force. Everybody, ये चीज समझ के चलना because this is important. This is the downward force that will be acting on this area will have some same force from below because this surface is not moving anywhere. The total net force on this surface should be 0. And if the net force on this surface is 0, then the force acting downwards should be equal to the force acting upwards. Right? Now the question is कि the force that is acting upwards, वो force कहाँ से आ रही है? मतलब what are the particles that are providing that force? That is the question. Right? That is the question you need to think over. नीचे से जो फोर्स लग रहा है वो किससे लग रहा है? तो इफ वी मेक अ एक्यूफर, क्या हम ऐसे बोल सकते हैं एक्यूफर का जो सरफेस है उसमें देयर विल बी सम ग्रेन पार्टिकल्स. एक्यूफर में लेट्स से इट इज अ सैंडस्टोन, सो देयर विल बी सैंडस्टोन पार्टिकल्स एंड between that sandstone particle there will be water, like there will be water in between, right? So this water will also have some pressure. So let's say that water pressure is P. Pore pressure कहते हो जैसे, water का pore pressure, let's call it small p, right? And the stress जो ऊपर की तरफ एक जो ग्रेन्स, जैसे मान लो ग्रेन्स पे जो फोर्स लग रहा है, ग्रेन्स विल प्रोवाइड एन इक्वल एंड अपोजिट फोर्स, राइट? दैट इज, लेट्स से इट इज इफेक्टिव स्ट्रेस generated by the grains, right? Whatever particles the aquifer is made up of. So जो ऊपर से फोर्स लग रहा है उस फोर्स के अगेंस्ट में कुछ फोर्स वाटर लगाएगा और कुछ फोर्स ग्रेन के पार्टिकल्स लगाएंगे. Is it making sense? Because both are here, right? तो ऊपर से जो फोर्स लग रहा है वो मान लो है सिग्मा टी. दिस इज द टोटल फोर्स एक्टिंग फ्रॉम द टॉप. ये कम नहीं होने वाला. यू अंडरस्टैंड? ये कम नहीं होगा, राइट? इसके अगेंस्ट में जो फोर्स लगना है उसमें काफी ज्यादा फोर्स लगेगा पार्टिकल्स की वजह से, सिग्मा टी, सिग्मा ई, and some force will be there because of the pore water pressure, right? So this should be sigma t should be equal to sigma e plus p, right? If I cancel the area, then this should be the equation. Whatever stress is acting from the top, that should be equal to the stress from the grains and from the water, because these are the only two things that will apply force. Now tell me, आ रही बात समझ लो? So Pallavi, okay, let me show you one more figure. कैन यू सी, इस फिगर को देखो ध्यान से, इन दिस फिगर यू सी दिस लाइन, यू सी दिस लाइन, ये लाइन दिख रही है आपको? दिस इज द इंटरफेस बिटवीन द ओवरबर्डन एंड द एक्यूफर, right? Now this line, there will be some force, because ऊपर से there is force acting because of the burden, that is sigma t, that is the overburden pressure, वो तो लग ही रहा है, right? You cannot, we cannot deny that, that is anyways acting. Now to counter that, because this surface is not moving, that means equal force should be from below, right? That force, and now these particles are made up of some spherical grains, some clay particles, right? Effectively they will be applying some force in the upward direction, right? That is because of the rock particles, we are calling it sigma e, right? And there will be some force because of the pore fluid pressure. If I make it with red color, there will be some force because of the pore fluid in the upward direction, because hydrostatic it will be in same in all the direction, it is pore fluid pressure, right? So that will also be contributing, but we know that contribution of that will be very small, but of course there will be some contribution, right? So if I have to write an equation balancing the force, because area is constant, I am just balancing the stress because it is the same thing, right, Pallavi? So the total sigma t from the top should be equal to sigma e plus pore fluid pressure, yes or no? Because from below these are the two forces and they should together be equal to the total from the top. Now tell me, is everybody clear on this? Everybody, Khyati, Himanshu, Anil. Okay. Okay. Now, understand again. This is the situation in which aquifer is there. जितने भी एक्यूफर्स हैं वो इस सिचुएशन में है कि नहीं? इसी सिचुएशन में, राइट? देयर इज अ बैलेंस. Okay. Now we know there are two types of aquifers, right? We know there is a confined aquifer and there is an unconfined aquifer. Let's first talk about a unconfined aquifer, which is this one, right? This is an unconfined aquifer and this is a confined aquifer. But let's understand this one first. Okay, unconfined. Now, first we'll talk about specific storage. अब ये चीज जरा ध्यान से समझना, ओके? स्पेसिफिक स्टोरेज का मतलब क्या होता है कि फ्रॉम दिस एक्यूफर कैन आई टेक आउट अ पीस that is 1 centimeter by 1 centimeter by 1 centimeter or 1 meter by 1 meter by 1 meter, a cube. I'm not taking it out. Imagine there is a cube inside this. Okay? You can imagine this unit area inside this aquifer anywhere. Doesn't matter, anywhere below the water table, anywhere. Can you imagine this? Inside this aquifer, imagine a cube of 1 by 1 by 1. 1, 1 and 1. This is the, so the volume will be 1 meter cube, right? If the volume is 1 meter cube, what we say, we can say it as a unit volume, yes or no? We can say this cube as a unit volume. If my unit is 1 meter, this is 1 meter cube. ये clear है सबको? Okay. Now what I am going to do? What I am going to do is I will drop this head. This is the head, right? Water head यही है. I drop this head by 1 unit. If I drop this head by 1 unit, tell me what will happen. सोच के बताओ, अगर मैं ये हेड को 1 मीटर नीचे ड्रॉप कर दूं, that means I am removing the pressure, right? From water I am removing the pressure. तभी तो हेड नीचे आएगा यार, yes or no? If I decrease the head by 1 unit, that means I am decreasing the water pressure, yes or no? So if I am decreasing the water pressure, I know that this was my equation, right? Sigma T was equal to sigma E plus rho plus P, right? Pore fluid pressure. This was my equation. If I decrease the water pressure, will my total sigma decrease? Yes, okay. क्यों? प्रकाश क्यों? Use your mic. Tell me why. Why do you say कि the total pressure that will increase or decrease? ऐसा क्यों लगता है? If I decrease the water pressure, you are saying total sigma will decrease. देखो, if it again tell me, if I talk about any unconfined aquifer, if I change anything inside the aquifer, will the total overburden have any effect? Will there be any effect on the overburden? Yes, Swati Lekha is absolutely on point, right? Because if you're decreasing water pressure, will that have any effect on the rocks that are above the aquifer, the overburden? No, if there is nothing like that, then in that case your pressure should not, your total sigma should not change, right? Means in this equation, sigma T should not change. My P is decreasing. If my pressure is decreasing, sigma T should not change. It is independent of it, right? Yes or no? Is it making sense? So if it is independent, sigma T is same, your P is, your water pressure is decreasing, then your effective sigma should increase to maintain the balance. Yes. Is it making sense to everyone? Total sigma T will not change, right? Because it has nothing to do with aquifer. It is the total thing that is lying above the aquifer. So that is never going to change, right? Khyati, समझते चलो इसको, right? वो तो ऊपर वाला तो नहीं चेंज होने वाला है. Now what is happening is if you are decreasing the pressure of water, तो इस फोर्स के अगेंस्ट में, ऊपर से जो फोर्स लग रही थी उसके अगेंस्ट में जो वाटर का कंट्रीब्यूशन है वो कम हुआ है, तो ऑब्वियसली ग्रेन का कंट्रीब्यूशन बढ़ जाएगा, बढ़ना पड़ेगा. ये बताओ समझ में आ रहा है कि नहीं? अगर हम सिग्मा टी तो वही है, सिग्मा टी चेंज नहीं हो रहा, लेकिन अगर हम वाटर का जो कंट्रीब्यूशन है उसको अगर कम कर दें तो ग्रेन का जो जिससे एक्यूफर बना हुआ है उस ग्रेन्स पे ज्यादा प्रेशर आएगा. दैट इज द होल थिंग. ये कंसेप्ट क्लियर है कि नहीं? तो नाउ कमिंग बैक टू द कन्फाइंड एंड अनकन्फाइंड थिंग, टेल मी कि इफ आई डिक्रीज द वाटर प्रेशर, राइट, बाय डिक्रीजिंग दिस हेड कम कर रहा हूं, मतलब प्रेशर कम हो रहा है, राइट? So if I am decreasing the water pressure, the aquifer will be under more pressure. The effective stress will increase, right? So if the water pressure is decreasing, the aquifer the particles of aquifer will be under more pressure now. ये पॉइंट अच्छे से समझ में आ रहा है कि नहीं, ये बताओ. किसको नहीं समझ में आया? आई कैन रिपीट. दिस इज द सोल ऑफ स्पेसिफिक स्टोरेज और स्टोरेटिविटी का. दिस इज द सोल ऑफ दैट. Pradeep and others. Is it clear? Is it making sense? Okay. So next step is, okay, तो तुमने क्या किया? तुमने हेड कम कर दिया. ठीक है. सो नाउ जो हेड कम हुआ, राइट, उससे तुम्हारे एक्यूफर पे जो प्रेशर था वो बढ़ा, बिकॉज वी हैव सीन दिस विल इंक्रीज. So if the pressure on the aquifer has increased, हो सकता है कि एक्यूफर कंप्रेस हो जाए. यस और नो? सोचो एक्यूफर थोड़ा कंप्रेस नहीं हो जाएगा ना. देयर विल बी कंप्रेशन ऑफ एक्यूफर इफ आई रिमूव सम वाटर, मींस इफ आई डिक्रीज द हेड. यस बोलते चलो, क्योंकि ये समझना जरूरी है. तो अगर ऐसी सिचुएशन आती है तो एक्यूफर का कॉम्पैक्शन होगा कि नहीं? एक्यूफर का कॉम्पैक्शन होगा कि नहीं? एक्यूफर का कॉम्पैक्शन होगा. नाउ इफ एक्यूफर का कॉम्पैक्शन हो रहा है प्रदीप, तो पोर साइज कम होंगे, राइट. सो एक्यूफर का प्रेशर, एक्यूफर का कॉम्पैक्शन हो रहा है, पोर साइज कम हो रहे हैं. तो पोर साइज अगर कम हो रहा है तो एक्स्ट्रा वाटर है जो वो निकल जाएगा कि नहीं? कुछ एक्स्ट्रा वाटर, पोर का साइज कम हो रहा है ना, राइट. तो पोर का साइज कम हो रहा है अगर, तो उस पोर में जो वाटर था वो कम वाटर है, तो एक्स्ट्रा वाटर होगा कि नहीं कुछ, अगर तुम पोर का साइज कम कर दो. तो दैट एक्स्ट्रा वाटर विल बी coming out of this aquifer. Is this clear? That is called as specific storage. So I am saying कि if the head is decreasing, then the aquifer will be under more pressure, right? More stress, and because of this more stress, there can be compression of the aquifer, or you can say compaction of the aquifer, right? And because of that compaction, the pore fluid, right, the pore fluid, because of that compaction, will release some water, right? Because let's say this was the size of the pore, right? There was water in it. Now if the pore size has decreased, this extra water will come out, right? That extra water, yes, tell me.
Yes, sir.
So that extra water is the specific storage. But there is one more contribution to this. What is this one more contribution? This one more contribution is expansion of water. मतलब this इसका बहुत ही कम शेयर होगा उस जो वाटर निकलेगा, बट देयर विल बी सम शेयर ऑफ इट. कैसे? देखो, अगर तुम किसी का प्रेशर कम कर दो तो वो दैट थिंग विल एक्सपैंड. यस और नो? If you decrease the pressure of anything, will that thing expand? But solid में the expansion is very small, very little, right? If you keep some solid under pressure and if you remove the pressure, वो हल्का बहुत ही कम expand. The expansion will be unnoticeable, right? That will be unnoticeable expansion. In liquid, the expansion will be little more than solid, and in gas the expansion you can literally see, right? Remember, जब वॉल्केनो से ऊपर गैस आती है, जब वॉल्केनो में जब गैस आती है तो ऊपर आती है तो हम बोलते हैं ना कि प्रेशर कम हो रहा है, तो वॉल्यूम एक्सपैंड करता है, राइट? राइट. सेम थिंग व्हेन यू आर डिक्रीजिंग द पोर वाटर प्रेशर, if you are decreasing the pore water pressure, then the water will expand a little bit. Yes or no? Will it expand a little bit? So then specific storage में the contribution will be of two things. First, it will be due to compaction of aquifer, right? Because compaction of aquifer will release some water, right? If the aquifer is compacted, it will release some water. Plus, there will be some water because of expansion also. Some volume because of expansion of water. This is a very small contribution. Major contribution comes from here. Anything, Prakash. You basically change the head by removing water, right? किसी भी तरह से, if you are changing the pressure by pumping out more water, जो भी, you just have to decrease the pressure. So now I will give you the definition of a specific storage. ठीक है? Tell me, did you understand it or not? It is unit volume of saturated porous matrix in a unit volume. So you are looking at a unit volume, right? This one, right? From this unit volume, if the head is decreased by 1 unit, the amount of water that is released from 1 unit of volume is specific storage. So it is the amount, the volume of water that is, right, per unit volume, per unit drop in head. It is the amount. Just imagine this is your cube, or this is your 1 unit cube of the aquifer. It will have some water in it, right? If I decrease the head by 1 unit, from this unit volume there will be some water that will be released. Yes or no? Because of 1 unit decrease in the head, there will be some water that will be released by this unit volume. That is called as specific storage. Okay. Achha, now let's talk about the unit of this specific storage. So it is volume of water released. So that is meter cube. If we are talking about volume of water released, it will be meter cube, right? Per unit volume of water released per unit volume and per unit head, per unit drop in head, right? Can everybody see this? Volume of water per unit volume of the aquifer per unit drop in head. Unit will be 1 by m, length inverse. But understand one more thing. For an unconfined aquifer, remember, ये चीज जरा ध्यान दो. For an unconfined aquifer, there is no, understand, there is no confining cover, right? Yes or no? For an unconfined aquifer, the water is not under pressure, right? Atmospheric pressure. Bolo yes or no? For an unconfined aquifer, the water is at atmospheric pressure only, right? So for unconfined aquifer, your specific storage, right, will be equal to, or storage coefficient अभी हम देखेंगे, will be equal to specific yield. Because you see, only gravity is, if you are dropping the head in the unconfined aquifer, it is just the water that is released because of the gravity influence, right? There is no confining pressure in an unconfined aquifer, right? So I'll come back to this, but remember, let's talk about confined, because you see, specific storage is defined majorly for confined aquifer. Okay, specific storage is defined or defined aquifers. In that only we can talk about the pore water pressure, because in confined aquifer only you have water which is under pressure, right? So if this is your piezometric head, understand, this is my piezometric head, everybody relate to it. This is your piezometric head. You are dropping this piezometric head by 1 unit. Then the water that is released will have two contributions. One coming directly from compaction of the aqueous, and another from the expansion of water. Two things are happening. One is compaction of aquifer and expansion of water. These two will contribute to the specific storage of confined aquifer. Is this clear? So confined aquifer is volume of water released per unit volume of aquifer per unit drop in head. So the unit will be 1 by L. L is length. Length unit means I am talking in terms of dimension, right? Or you can write meter inverse. This is unit of a specific storage. Tell me, is this clear? But understand, specific storage is only talking about 1 unit volume, right? If I have to talk about the whole aquifer, then comes the concept of storage coefficient or storativity. Storativity and storage coefficient is the same thing. Okay, they are the same thing. So storage coefficient, which is generally given by S. So if you're talking about only unit volume, it is specific storage. So let's say कि हम 1 meter by 1 meter का area ले रहे हैं अगर, this is 1 and this is 1. So if you're talking about unit volume, then you will go only 1 meter below. Yes or no? If this is 1 by 1, to talk about unit volume, you will go only 1 unit below. Yes or no? But if you have to talk about the whole aquifer depth, then you have to go the whole depth, right? Let's B, right? So it will be specific storage time B, right? If this is unit area, then specific storage is only going 1 meter below or 1 unit below, right? Understand this. If it is unit area on the top, if you are taking only unit area on the top, then specific storage will only go 1 unit below because it is per unit volume, right? But if you have to talk about the whole aquifer, then you have to go till the whole depth of the aquifer. That means your total storage of an aquifer, which is storage coefficient, will be equal to specific storage into so this will be B. So remember, storage coefficient is equal to specific storage into depth of the aquifer. एक बार concentrate करके सुनो. Specific storage is एक्यूफर का 1 यूनिट वॉल्यूम अगर मैं ले लूं, ठीक है प्रकाश, एक्यूफर का 1 यूनिट वॉल्यूम ले लिया मैंने, उस वॉल्यूम को देख रहा हूं मैं. नाउ आई एम ड्रॉपिंग द हेड बाय 1 यूनिट. whatever water is released, that is my specific storage, right, from that unit volume, not the whole aquifer, right?
Yes, sir.
Now instead of taking unit volume, means unit depth, अगर the top area is only 1 by 1, the top surface is unit surface cross 1, then if I have to take the whole depth, then I am not just taking unit volume, I am just taking this unit area. Anything below this unit area will be considered, right? So storage coefficient will be, understand, volume of water released per unit area of aquifer, per unit drop in head.
Okay.
अब अगर मैं तुम्हें, चलो लेट्स डू इट अगेन, इसको फिर से समझो कि पहले अंडरस्टैंड दिस इज 1/1, ठीक है, दिस इज वी आर टॉकिंग अबाउट एसआई यूनिट, लेट्स से दिस इज 1 मीटर एंड दिस इज 1 मीटर, ठीक है,
Yes, sir.
ये स्टार्टिंग है एंड दिस इज वी आर टेकिंग दिस यूनिट एरिया बोथ फॉर स्पेसिफिक स्टोरेज एंड फॉर स्टोरेटिविटी बोथ, राइट है. नाउ इफ यू वांट टू टेक यूनिट वॉल्यूम you have to go 1 meter below, right? If I am going 1 meter below, this will be cube, yes or no? This gray portion, everybody understand this. If I go 1 meter below, then this gray portion, this will be 1 meter cube because surface area is 1 meter square. ये समझ में आ रहा है कि नहीं? Is this making sense? So if I drop the head by 1 unit, then whatever water is released from this volume is called as specific storage. ठीक है, मतलब volume of water released per unit volume of the aquifer per unit drop in head. So this becomes a dimensionless quantity. No, this becomes 1 by meter. Now if I talk about storage coefficient, I am not talking about the whole aquifer. I am talking about whole aquifer below this unit area. I am not changing the unit area, but I am talking about the whole aquifer below this area. Not the, अगेन एक चीज मुझे समझा लेने दो फिर से कि तो जो एक्यूफर है ना प्रकाश, वो एक्चुअली बहुत बड़ा एरिया है, राइट? लेट मी जस्ट मेक इट सो दैट यू हैव एन आइडिया. दिस होल एरिया इन 3D, एवरीवन अंडरस्टैंड, इज द होल एक्यूफर. दिस इज अ वेरी बिग एरिया, ठीक है, दिस इज अ वेरी बिग एरिया विच इज द होल एक्यूफर. आप ऊपर देख रहे हो. आई एम जस्ट टेकिंग 1 meter square area of this aquifer. Is this clear? I am just taking 1 meter square area of this aquifer. Below this, I am taking only 1 meter depth. From that unit, if the water is released, whatever water is released from that unit volume, that will be my specific storage. And whatever water is released from this whole aquifer below this unit area, whatever water is released from this aquifer, whole aquifer, that is your storage coefficient. Is this now making sense? We are not talking about the whole aquifer in the region. No, we are only talking about a aquifer that has unit area. उसके नीचे if you take a unit volume, whatever water is released from that is specific storage, and if you take the whole depth below that unit area, is your storage coefficient. Is this making sense now? So now do you understand that storage coefficient will be specific storage into the depth of the aquifer below that unit area, not the whole area of the aquifer, just below that unit area, whatever depth is there, that will be your storage coefficient. So remember, a specific storage has a dimension of meter inverse and storage coefficient is dimensionless.